Hello Internet. I'm going to be talking about functional programming in JavaScript using the Ramda functional programming library. Now there are multiple ways of writing code. There's procedural, there's object-oriented, functional, there's multiple different styles of programming, and in this talk I'm going to show two different ways of writing the same code. One is very imperative or step by step, and the other one is functional using functional programming techniques. And now, like I said, I'm going to be using primarily the Ramda library to illustrate this. So what I'm going to do is just start coding. Basically, what we're going to do here is we are going to create. It's a very simple application. It's really not even an app. It's more like just a demonstration or a proof of concept. We're going to create a bunch of numbers, and then we're going to filter them, find all the even numbers, and then we're going to square those even numbers, and then find the average of those numbers. So it sounds pretty simple, and it's not too bad, but it'll actually illustrate a lot of functional programming concepts along the way. So I'm just going to go ahead and get started. I have a blank directory right here, and this is going to be, like I said, this is JavaScript. We're going to be using Node. I currently have using the Node 750 for this. Yeah, so any version of Node should work. The first thing I want to do is create a package.json file. So I'm going to say npm init, and it was just going to ask me a bunch of questions, and then there it is. Now I want to install the Ramda library. Now the Ramda library, ramdajs.com. This is it says it's a practical functional programming library for JavaScript programmers. So it's a pretty good library. It's actually very popular. So if you want to do functional programming stuff in JavaScript, it's one of the better libraries, if probably not the best in JavaScript. So this is it, and if you want to install it, you just npm install it. So we're going to npm install. So this is going to add the Ramda library. So if you look at this package.json file, there's Ramda. It's version 0.23. So that's that, and then I'm going to create a file, of course, and then this will be the file that we're going to edit and where our code is going to be at. I'm going to be using VS Code. If you haven't used VS Code before, it's a really good editor, really for most languages. But I used to use Atom, but Atom and Visual Studio Code are both Electron-based apps, but I think VS Code is actually better. So anyway, I'll be using this editor. Just as a side note, this terminal right here is called Hyper. It's also an Electron app as well too. So for those that don't know, Electron is a Node app. It runs Node in the back end. So this is basically I'm writing Node using a Node terminal and a Node editor. So JavaScript all the way around, I guess. Okay, so let's go ahead and get started. So here's my file, and yeah. So the first thing is I have Ramda already installed. So I'm gonna actually before I do that, I'm gonna show you how to do this imperative, or you can think of it as step by step, where you kind of tell the computer every instruction, and then we're gonna do it what I would consider the wrong way first, and then I'll show you the right way of doing it, or not necessarily the right way, but just a different way of doing it. So let's just start. So I'm going to use since this is Node 7.5, it has a bunch of ES6 features in it already. So instead of using var, we're going to be using things like let and const. Those are better to use anyway. So I'm going to start off with this. Let total is equal to 0. So we have a variable called total. Well, I set it equal to 0. I have this thing called count that is going to be also equal to 0. And what I'm going to do, basically, I just want to create an array of, I want to go from like 10 to 20, let's say, and I want to count up all the even numbers and then square them, and then find the sum and then the average. The sum, of course, being the total, and then the average being the total divided by the length. So we'll just, it's a very simple thing, but I'm going to show this imperatively and then declaratively using functional syntax. So a super imperative way of doing this would be using a for loop, where you can say let I is equal to 0, I is less than or equal to 21. Sorry, less than 21. So that's 20. Actually, I want to go from 10. And then we're going to say I plus plus. So there's my incrementer. So there we are. We're starting at 10. So the first thing I want to do is, so I'm going from 10 to 20. Basically, yeah, it's going from 10 to 20 since 20 is less than 21. Next thing I want to do is I want to say if I is so what that's saying right there is if I divide I by 2, if the remainder is 0, basically this is saying if that value I is even, then do something to it. So do what to it? Well, I want to add it to total. So I'm going to say total is equal to itself plus I squared. The I squared, that's not actually ES6. I believe it's ES7 or ES8 syntax, but it's actually already supported in Node, so you can use it. So this is basically taking I, squaring it, and it's adding it to total. So we're just squaring all the numbers that are even, and then adding that to total. Also want to take count. And so every time that I add a number up, I'm gonna basically the total is a sum, and then count just keeps track of all the numbers that I'm adding. Then at the bottom, all I'm gonna do is I'm gonna say let average is equal to total divided by count. So total is a sum, count is how many there were, and then we can say, yeah, we can just print this out. So if I were to run this like this is the average is 236.6. So this is pretty good. It's not really a lot of code, but it shows a very imperative style. If you were to look at this code, you would say, well, what is he trying to do? And you'd have to look at you say, well, there's a loop going on here. It looks like there's some Boolean expression, some condition. If it's true, looks like I'm trying to add something up. So it's not quite 100% obvious what's happening. Now, obviously, there's only 10 lines of code, so it shouldn't take you forever to figure it out. But the code is very imperative. So what we're going to do is we're going to take this code instead, and we're going to make it declarative or functional. So basically, I'm just going to copy that out and start and show you the what I would consider a more correct way. Even though this what I'm about to show you is more code, it's probably, in my opinion, better. So I want to bring in the Ramda library. So I'm going to say const r is equal to require. So bringing in that node module. Now we're going to use it. Now what I want to do is I sort of want to break this thing up here at the top. I sort of want to break it up into functions. So when we're talking about functional programming, at the heart of functional programming is functions. So how can you take something like this at the top, these lines 1 through 10, and break it up into something more functional? So let's start off with these numbers. So I'm starting off, I'm saying go from 10 up to 21. Well, what does that mean exactly? What if there was another way of creating a range of values? So in Ramda, there is a function called r.range. And what is nice about Visual Studio Code or VS Code is it actually, even though JavaScript is a highly dynamic language, it actually knows what is inside of Ramda. So you can say r dot, and it actually shows you all the functions in there. And even when you do that, it even shows you what the parameters are to each function. So so it's pretty good. So r.range. What this thing does is it actually takes it takes two values. So you could say give me 2 to 10 as an example. Let's say let x, just as an example. So what it does is it shows you 2 is the starting point and then 10 is the ending point, but it doesn't actually include the ending point here. So it actually goes 2 to 9. So if I wanted to go from 10 to 20, you'd have to say that, and there it is. So this already is more declarative because you're saying I want to range from 10 to 21 or 10 to 20 versus up here you're saying for let I equals yeah, this is more imperative. This is a more declarative way of saying like the same thing. Now this is kind of interesting what I just wrote right here, but something that is even more interesting is you could actually leave off this second parameter or the second argument, and when you do that, and if I rerun it here, you can see over here on this side that this thing actually changed from an array to a function. So Ramda does automatic currying, and so that means basically what that means is you can take a function that takes multiple parameters, and currying turns it into a function that that if you call it, basically, sorry, let me say that again. It basically takes a let's say you had a function that takes 3 parameters. It can actually currying basically means you take that into a function that can take 1 parameter at a time. So here, for example, when I said r.range 10, what that's actually doing is that's passing in 1 parameter, but because there's 1 parameter left to go, this is the minimum value. It still needs the upper end. Because you didn't supply it, this function right here is called partially applied. So you're partially apply means call. So you're partially calling this function. You're giving it like half its value, and so x is basically the rest. X is basically the function that results from it. And you can actually, using Visual VS Code, if I said x parentheses, it actually shows 2 number. So the IntelliSense is basically telling you you still need the other value. So I could say 21 here, and actually that's not. Let me do this. And then run that, and then we're back to the same value. So because I partially applied this function, I pass in 1 value. The x is basically the other. It's a function that takes 1 more value. So that's how currying works. So what I can do here is I can say, well, what if I wanted a function? Let's call it const from 10. And what this will do is this will give you, it'll start at 10, and then from 10, we'll start from 10, and it'll go up to whatever you want. So same as before. So now I have this function called from 10. So if you were to see this from 10, it means go from 10 to 21. Of course, 21 is it doesn't actually include the value 21. So that's pretty interesting. So we already have something very functional that's sort of replacing this for part. So that's pretty neat. What about this even on line 4, where I'm checking if I is I mod 2 is 0? That is even check. what's another way of checking if something's even or not? So once again, this is functional programming, so we're trying to convert all these things into functions. So what if I created another function called isEven, and that would take some value n, right? Some number n, and it'll give you back. What I want to know is if n divided by 2 or mod 2, is that equal to 0? So isEven is a function that takes a value, and because it returns, this is an arrow function in JavaScript ES6. So it actually returns this value. So a number comes in, and then a true or false comes out. So that's why I called it isEven. So if it's true, if this is true, then isEven is true, and if it's not, then isEven is false. So I've replaced this if thing with this isEven function. So once again, functional programming is about creating functions and then composing them or combining them together. But we'll talk about the combining later on. Now there's a the squaring thing I'm doing right here on line 5. How could you square something functionally? Well, you could create a function that takes in a value, let's call it n, and it returns n squared. So I take in some value n, and it will return the square of it. So once again, I've taken this thing and made a function out of it. All right. The next thing is here I'm summing. Well, yeah, on line 5 right here, this is summing some stuff up, summing some numbers up. How could I do that here? How could I sum something up? Well, in JavaScript, just in plain ES5, there's a reduce function on the array class, so I can just use that. So let's create a function called sum, and what that'll do is we'll give it some numbers. So we'll say nums plural, meaning I'm going to take in some numbers, ostensibly an array, and that's the input. And then what I want to do with those numbers is I want to reduce them down. Now this isn't Ramda. Now Ramda does actually have a reduce function, but we're going to use the function that comes with ES5. So how this works is reduce takes the first value is the accumulator. We'll call it the total. And then the second parameter is a current value. We'll just call this num. And what happens here is it returns okay. So what's happening here is that nums is an array, and basically what happens is, let's say the array is 1, 2, 3. The 1 would go into total first, and then the 2 will go into num, and so then that would be 1 plus 2 is 3, and that gets returned, and that return value goes back into total. So then the 3 would go back into total, and then the 3 from the remaining part of the array goes into num, and then that would be 3 plus 3, and that would become 6. So if nums was an array of 1, 2, 3, you would actually get out the number 6 if you called it. So that's how it works. You noticed that I said total actually takes the first value. There's actually a second parameter to this. You can say 0, and that's the initial value. So if you put that in there, then 0 would go into total first, and then 1 would go into num, and then 0 plus 1 is 1. That would be total. And then the next one will be 2. 1 plus 2 is 3, and then 3 plus 3 is 6. You can put this initial value 0 there if you want, or you can just take the first value from the array. So that's sum. That's how you would sum up some things. Sum up an array of numbers. The next thing I want to do is, what if I wanted to find the length of something? Now, obviously, you can take so let's say I had an array nums dot length. That's one way, obviously, of finding the length of, say, an array. But I want to make this more functional. So I'm going to create a function called length, which will take in some array nums, and it will just return nums.length. So the function is this function length is abstracting away the fact that I'm actually under the covers just calling the length property on the nums array. So that's length, and then finally I want to find the average. So how do you find the average? Well, you have to pass in obviously an array, and all you have to do is find the sum of some number of nums divided by the length of nums. So so you can see this is very functional, right? And then you may have also noticed in all these functions, they're all operating on data passed in. So these are what's called pure functions, which means they don't modify any external state. There's no side effects, and if you give them the same input, they'll always give you the same output. So these functions are all pure, which makes them really easy to test. Now you're probably looking at this and going, wow, there's a lot more code here potentially than this code up here. And while that may be true, these functions, because you pulled them out of this up here at the top, this is a lot more flexible. It's super testable, so it's really easy to test, and not only is it easy to test, but it's also repeatable, it's predictable, and you can then use these functions in other parts of your program. If you had a program that wanted to find out something was even, if you want to square something or whatever, these functions could be used in multiple places of your program, versus this code up here at the top, it was all kind of jammed together. So now that we have all these functions, we want to put these functions together or compose them. Ramda has this function called compose, which takes in a bunch of functions like function 1, function 2, function 3, and it puts them together or composes them together. What happens when you do this is it actually would call function 3 first, and then so the data you pass in would go into function 3, its return value would then go into function 2, and its return value would go into function 1. That's pretty good. Compose is awesome. There's another way of doing this, and it's called pipe. Pipe does it just the opposite way. Pipe calls function 1 first, and then function 2, and then function 3. You can use either one. It just depends on which one you like. I tend to like pipe because it reads from left to right. But if you're more mathematical in nature, you may like the compose better. So how can I pipe these things? So what I'd like to do is I would like to start from 10. So I could say from 10. Now this from 10 that I have right here is a function, right? Line 14 is the from 10 function. Now it is a function, right? So that means it needs some data. So this thing still needs some data. So what I'm going to do here is I'm going to create a function. Let's just call it f for right now. Later on, we'll actually call it something better than f. But for right now, f is fine. So if I were to call this function f needs some data. Whatever that data is will get piped into. That's why it's called pipe. That data will get piped into this from function. Remember what from does? It requires one additional value because this was partially applied. It takes one additional value, and then it will produce an array. So this thing will produce an array once it gets some value. Okay. Then once this array is created, it needs to pipe it or send it to something. So why don't we filter out the data? So you may be thinking, well, do I call the isEven function and filter out the data? The problem with that is that doesn't actually work. This is an array, and so I want the output of this thing to be an array, but of course you can see right here, the output of this is not an array, it's a Boolean expression. So I need a way of taking in an array of values and filtering them. So Ramda has this thing called filter. And how it works is Ramda.filter. It takes it takes a function and then data. It takes a function and then data, then data to filter. So, but because I didn't supply the data, this is a partially applied function. This is actually giving me a new function. So I'm not. If this code were to run just as is, it wouldn't actually do anything. I'm passing in a function into filter, and this is giving me a new function. This new function allows me to pass in an array of numbers, and then if it passes this expression, then a filtered, think of it as a subset of that array will come at the end. So from 10, once I give it data, it will produce an array. That array will then go into this function, and each value will get evaluated to determine if it's even or not. And if it's even, a new array will get created that of even values. Then once I have an array of even values, the next thing I want to do is I want to square those. Well, how do you take a value and square it? That's called a transformational function. More specifically, it's called a map. So in Ramda, I can use the map function. So map takes data. It takes a function and then some data. Once again, you notice in all these things, there's no data here, there's no data here, there's no data here. The data will get provided by f. Once I call f, then that's the last piece of information you need, and that will actually help all this stuff run. But for right now, these are all partially applied functions, which means they're still waiting basically on their last. They're waiting on their last parameter to get filled. He needs his last parameter, filter needs the last parameter, map needs the last parameter. Now, once map is done, map is going to take the values that were the even values, it's going to square them, and then after that, it's going to find the average. And then so what is AVG? AVG is here. It takes an array of values, which is good because map is going to give you an array of values, and it's going to sum them and then divide that by the length. So yeah, here we have a very nice pipeline. This creates an array. This filters the array. This transforms the array, and then finally, this is called a reduction operation, which reduces that array down to a single scalar value. So I have this function f. F is not a very good name. How about instead of calling it f, how about I call this thing average even squares from 10. So it take from 10, it's going to find all the even values, square them, and find the average of that. It's a bit of a tortured name for a function, but it is useful. So this thing is now a function. So if I were to say const result, and I were to call this thing, it knows I need to provide it a value, so we can go 21. Remember how range works. Range is the from 10 calls this range, and now because I've partially applied the first value, this is going to give me the second value, so now it'll be completely applied. So now it will go from 10 to 21, create that array, then it'll get filtered, find the evens, it'll square all the even values, and then it'll find the average. So finally, if I were to print out the result of this. The other one gave me a value of 236.6. If I were to do this one, 236.6. So you can see this code here actually gives you the same answer as this one up here. Once again, you may see this code from 1 through 10, and then the code and compare it to this code and say, wow, the code on the bottom looks more complex, and it probably does on first sight. But once again, the code on the bottom is more it's more composable. This isn't composable at all. So this is way more composable. It's more usable, reusable. It's more modular. It's more testable. It's just better all the way around. Yes, there is a little bit more code, but because you can potentially reuse all these functions in different contexts, then it's more useful. That's about it for this talk. I'm going to be giving more talks and more demos on functional programming, on Ramda, giving more in-depth demos of how it can be used in different contexts than just squaring even numbers. So I hope you liked it, and thank you for watching.